say that homework 1 is now posted, and the goal of homework 1 is for you to build an RPG item system, effectively an API. And really the assignment goal here is for you to create your own. I said RPG item system, but I can, I'm open and flexible for you to design whatever you might envision. But this might, I think, conceptually might be a little bit easier thinking of that as an art. Another type of game where this would work well is like an item, like a crafting game system, like Minecraft or like Don't Starve or something like that. So you can use the lecture code as a reference for this. What I want you to do, though, over the course of this assignment is to effectively use interfaces and classes. And by effectively, what I mean to say is you use them like a professional would use interfaces and classes, and not like what a student would use interfaces and classes for, like in a student project. And towards that goal, I want you to author JavaDoc documents. So I want you to use JavaDoc comments inside of your homework files so that you can run the JavaDoc on it and generate the HTML that would actually create an API. Because again, the idea here is we're not creating a game. We're going to create an API that games could use that's going to create a very diverse item system. And I also want you to perform JUnit tests. And JUnit test isn't hard. We just did that throughout this lecture, and you'll have access to the video, and you'll have access to my source code after today's lecture. So you'll be able to use that for your homework as well as a concept. But I think it's very important that repetition is key when learning things like using auto documentation tooling and auto testing tooling. So I'd like to try to integrate those two tools for the remainder of the projects that we use moving forward. But at the end of the day, for this particular assignment, the item system should contain multiple interfaces, abstract and concrete classes. Because again, I want to make sure everyone feels super comfortable in object-oriented design, and object-oriented design that makes use of inheritance and especially interfaces. So the system should be designed with these goals in mind: reusability, flexibility, and robustness. So note, the item system may be used as the basis for future homework projects, but it's not intended to be a game in and of itself. So it's not a big complex project we're working on here. And that's why JUnit testing will work really well in terms of evaluating and testing your code base. So what are the learning objectives here? What is it that I want you to get out of this assignment? Well, you have to perform object-oriented decision-making for designing your project. You must effectively use interfaces to design a compelling and deep item system that is, again, reusable, flexible, and robust. Those are going to be the keywords I keep falling back on. And for some, this may be the first time that you're building something of your own in Java in such a robust way. And so just to highlight the learning objectives, it'll illustrate that you're competent in OOP, inheritance, and polymorphism, that you know how to effectively use interfaces, abstract classes, and concrete classes as Oracle scribes. You should use them for the curator of Java. It'll illustrate also here, we've had lectures about design by contract and programming to the interface. And so again, programming to the interface is what we do when we use an API. Here, you're effectively creating your own API, and you should be making your own API by defining it on a set of abstract methods, hence interfaces, the actual Java interfaces. So I want to make sure everyone understood the concepts we lectured about on, I want to say that was lecture 3, and make use of them. I want to make sure everyone has a solid understanding of how to use JavaDocs to generate an API. So that's a big learning objective. And then I want to make sure that everyone knows how to do unit testing on their own classes. So I want you to also include your unit test classes for that and illustrate that I should be able to run those and they should all be able to pass. Okay, so some implementation advice for you. I want you to focus on defining interfaces that define behaviors that items may implement to qualify as a member of that defined trait. Okay, let me rephrase that. That's kind of, I want you to focus on defining as interfaces. So by interfaces, I mean the keyword Java interface. So you will have Java interfaces. So what are these Java interfaces? They're Java interfaces that will define a behavior that an item might want to implement. So remember, the keyword for implementing an interface is implements. And so when an item implements an interface, it then becomes a member of that interface. And that becomes a defining quality of that item. So what are things that items might be? And I will open this up to people who are here who want, so like flammable might be, and so what might be a function in flammable? Burn, right? I think I give that as an example. Edible, what might be a abstract method in the edible interface? It might be eat, right? Interface breakable. What might be a abstract method in breakable? Break, right? So think of like all these kind of abstract terms that some items might have, but others might not. Like you might be able to break a potion, but you might not be able to break a rock, right? So some can implement, so any item that implements breakable represents a breakable item. And any item that doesn't represents something that's not breakable. But you can see how you can start creating this abstract concept of how objects can then start inheriting from multiple interfaces that all define these kind of disjoint qualities that you might define as a characteristic of an item. And I want you to start thinking of object-oriented design in that way. Does that make sense? Is that a good explanation? Anyway, here's some tips to make it easier. And if it's not, please give me a question here before and I'll continue. I want you to start by planning out all of your interfaces that will represent effectively like a micro API. And each interface is going to contain those methods that represent that trait. So for example, the interface flammable might have one method, it'd be one abstract method that's burn. And every item that might be burnable would implement flammable, and it would then also have to implement a burn method. So you can see how this would work really well in a crafting game, or again, in an RPG game. Classes should implement multiple interfaces, and then you can use an abstract class and concrete classes in your design. Abstract classes should be the collection of correlated concrete methods and instance variables that multiple subclasses might share. And then concrete classes would be a very particular thing inside of your item system. And so your resources or anything that's available in lecture, anything that's available in lab, anything like, and also you can ask on Discord. If you want a simple example, I gave something in CodePen just to give you an idea of what I had in my mind. Really, like Minecraft is a good example of what I have in mind if you just want something without looking at it. But let's go to this quick demo so I can just show it off. So if I follow this, I can see, oh, here I have certain types of items. Like for instance, inside of this box, I can only put enchanted weapons. Inside the furnace is only things that are burnable. Inside of this chest, I can have items. So this represents a application that would make use of an item system. So right here, if I try to take this, I can't put that in there because only enchanted weapons can go in there. So I can pull this in there, right? And same thing here. I can put the carrot in the furnace. Oh, I guess I can't put the carrot in the furnace. I guess I could take the steak and put that in the furnace though, right? And so what's happening under the seams is it can check to see if the steak is a member of burnable or something that the furnace is looking for. And if it's not, it won't allow that thing to happen. So that just gives you a use case of how you might want to start thinking of your item system in the way it might be used by an application system. And so again, you might want to understand the motivation. Well, why would you even want to write something like this? What's the point of this homework? Well, it's OOP design practice, right? This was a complex hierarchical system, probably more complex than any that you've been challenged to think of. So I want to challenge you to think of something in this way so you can become more comfortable with it. And it's going to force you to create many different interfaces and classes with a variety of related and divergent elements. And so another nice thing about these kind of projects is it's a portfolio project, especially since I'm not giving you super rigorous specifications. So everyone's is going to be slightly different. So employers and recruiters commonly prefer candidates who have project portfolios to demonstrate their technical skills, and their passion and creative projects are often good additions for that. So here, the idea is that you can publish your end result onto something like GitHub. And GitHub has what's called GitHub pages. I'll work with all of you on this, where you can even have your Java API documentation hosted so that people can read your API document, download your item system, and actually integrate it into their own game. And so it'd be really cool for you to be able to say you designed your own API that was unit tested and is also documented. So that would be a good thing to highlight after you're done taking this class, to illustrate you understand how to do some of the professional tooling that you'd use in industry. Some inspirations you might want to consider using: think of any fantasy stories or games, sci-fi games. A cooking item system could be cool. Think of anything like crafting or a mini RPG. And I think I might do something, another like mini assignment like this after we get into the collections API, where you'll have to manage an inventory system. So, but before you can manage an inventory system, you need to have an item system that you can manage it on. So I do want to take this and bring it forward a little bit. And again, with JUnit testing, I want you to design a test plan for your item system. You should create a test fixture for each class and a test case for each set of methods you have, and make sure your test plan includes checking your routine, challenging, and edge case instances like what we talked about in lecture. For the JavaDocs, the JavaDocs represents your full API documentation and should be included with your item system. Your item system is designed to be used by external client code. So the API is your contract as an implementer with your clients. So you want to ensure that you use JavaDoc documentation to produce the necessary API files that other developers can use, your client developers can use, so they know how to use your system. And I'll answer questions right when I'm done going through the rest of these slides. Quick note on my rubric for this. So you can think of it as being broken into 4 parts, really 3 parts. You have the OOP part, which is half the grade. Your API is 20%, so that's your documentation and comments. And the JUnit testing, which is going to be your test plan and your test coverage, will be 30%. So that's kind of how the split on where the points are allocated. And then if you put a lot of work into it, for those outstanding submissions, I give myself leeway to give anywhere between 0 to 10% bonus points. And for submissions, well, the tools you're going to need for this is going to be Java, IntelliJ, JavaDocs, and JUnit 5. I've showed you how to use all those in our lectures already. So if you're not familiar, if you have questions, go back to the lecture videos. They're all posted on YouTube. And for submission, I want you to submit your source code to either GitLab or GitHub. I don't care which. Publish your HTML file into a doc folder of your project. So the HTML files are produced by the JavaDocs. And I grade very differently than most other professors or instructors in the department. So to receive a grade for any assignment, you have to schedule an audit with me, where you show off your code base and we walk through your implementation, and I give you in-person feedback about what you've built. So when you're ready for a grade, let me know, and then we'll do a Zoom chat and you can walk me through what you've designed and kind of show me your unit testing and give me an idea of how you've developed and designed your code base. So I think homework is super valuable for you to grow from, but I think you can only grow from when you get feedback on it. So keep that in mind. You won't get grades on your homework until you contact me and let me know you're ready to do an audit. And then we'll schedule a very quick, it'll be usually about 10 minutes, where we just establish a connection, you share your screen, and then we walk through your code base. Okay, so let me go through some of the questions. So in terms of due date, I'm still filling out the summer schedule. You have to realize that for each week that we're going in summer represents a 2-week period in fall or spring. So we do 6 hours of lecturing per week as opposed to 3 weeks. So I currently have this homework due on Friday, midnight at Friday, or like 11:59 on Friday of this week. However, I'm still getting used to the expedited rate of summer. So I hold the right to have that as a tentative due date and push that back. So I will work with the class to figure out what works with that. But right now, the tentative due date is Friday. But I'm not married to that due date. Okay, let's see. How should a user be able to interact with the RPG objects we create? Should they be able to stack things, or should things just be labeled as such? Well, that's a great question. Right now, we're not actually building an application, right? We're just going to build an API. So we'll be testing things using JUnit Test, or you could also create like a test classes if you wanted to that creates instances, but really you should just be doing that with unit testing. So you should test to see if things are stackable. And so I actually have code that everyone can start with. If you go into the Moodle, I shared a link to a repo that I've made public inside of GitHub called CSCI2120. Inside of CSCI2120, here I will put the PowerPoint slides, but here I have the homework documents. I have the lecture code that we've shared up to this point, and I'll also put the PowerPoint slides in here later today. And so here, even if we didn't produce code, I'll just create a README that says no code. That way, every lecture we have is represented inside of here. So the one instances we do have code was like lecture 3. And remember, for lecture 3, that's where I went over concepts with inheritance. I actually built out inside of IntelliJ a basic version of what I'm asking you to do. So I don't necessarily want you to be tied to my design, right? I want you to design your own thing. But if you want inspiration, I have source code files here, and lecture 3 covers over some of the concepts I go into with this. So you have a starting point here. So please make use of that. But I want something better than this. This is like something that was hacked together and not completely well thought out. So I want something that you could that is a little bit better thought out. Okay, let me see what other questions we have here. Would an item system for a store work? Yeah, item system for a store would work well. A pet store, for instance, idea. I think that's even more applicable than a game thing. Something that is part of a like a commerce site would be awesome, or something that is inventoriable. So if you created like a art collection site that kind of defined art based off of various interfaces, all that works. Like, be creative. And I naturally kind of gravitate towards the game things because I've, as an educator, that seems to be something that a lot of people tie themselves to. But I am all about breaking outside that mold and seeing what you can do with building kind of a mini API system that makes use of a lot of interfaces. Again, the idea here is I want to illustrate that interfaces are typically the thing that defines what objects can do, and they represent abstract classes, and that can define memberships across things that are normally disparate or different types of instances, but they all have this shared concept that they're flammable, or that they're carryable, or that they're equipable, or that they're edible, or that they're drinkable, or all these other things. So you can have a diverse set of things that normally wouldn't be related except for that property. And so we want to start thinking of designing our system from an abstract way down. And I think when you're in 1583, you do the opposite. You start thinking of concrete things and working up. But in the real professional world, we try to think abstract and then build our concrete things from abstract concepts, because it allows for more reusable and robust code. Whereas by designing concrete things initially, it ends up building things that are more brittle and more specific. Let's see here. I have one last question. Are we allowed to use the same files you made for the item demo? Yes, you can start with that, but I want something that's much deeper than that. I wanted to make like a Minecraft weapon thing, so I was thinking of using the breakable or consumable. Yeah, go ahead and use demo code. As I stated in the homework document, you can use whatever code that I initially gave to you as inspiration. It's not a bad idea because it gets you used to thinking in this mindset. But then I want you to expand past the limited scope that our little lecture code went with and build something that's a little bit deeper. Excellent. Is there any other questions, or does everyone feel a little bit more confident and comfortable with this assignment? And again, this isn't a full application. It's design to ensure everyone feels comfortable thinking about object-oriented design in a more complex way than you probably have before, and also to do such in a way that you produce your own documentation and your testing with JUnit testing. So I want to get people used to using the tooling you'd use in industry. Okay, so if there's no other questions, I'm going to go ahead and end today's lecture. Let's see, thank you. Does it have to be something like the furnace thing you showed us? No, the furnace thing I showed you was just something I came across. I'm like, oh, this is a good proof of concept to highlight to others what an item system could be used for. So the idea is that you might have an inventory system, and an inventory system would rely on an item system. But before you can have an inventory, you have to have an item system. And so when we start talking about collections and how we can start storing things and sorting through things and searching through things in different ways, it'll be nice to have an item system that we can then build an inventory system on later, just to get used to all these new concepts we're going to explore. Okay, so that's a great question. So I'm getting a question, still a little bit of confusion on what the code will do. So the code is designed to be used by a client developer. So you can think of yourself as an implementer of an item system, where the item system itself is not designed to be an application in and of itself. It's designed to be used by some other client developer who will use it to build a game. And so for this purpose, you're not building a full application. You don't have to have a main method, right? You don't have to build something that turns this into a game, but it has to be well developed enough that I can instantiate all the items inside your item system and start using them to build a game around. Does that make sense? So you could start thinking of yourself as an API developer, where you're building a set of interfaces, abstract classes, concrete classes, all of which have behaviors that will then have API documentation, the same type of API documentation you would have on, say, Oracle's website, and to ensure that all of your classes and interfaces and methods will work for the client as you expect. You will JUnit test it, since you're not developing an application yourself. You'll JUnit test it to ensure that they work well enough to be integrated into someone else's code base. Yeah, so yeah, it's essentially aspects of an inventory without having to do the inventory. So it would just be all the individual items. Now, hint, hint, we will extend this to actually build an inventory later on. But in order to make this easier, we'll start by just doing the item system as our first homework, which is a small thing. Like, this isn't designed to be a big thing, which is why I set the due date to be Friday, right? Because you're not building a full application from this. Although I do want a deep enough item system where maybe you have individual pieces of armor, individual weapons, and then you have like a base weapon that all of your sword and your poleaxe and your mace might inherit off of. And then you might have things like maybe you can have different attack types that are interfaced. Like you can have what are like piercing, or you could have bludgeoning, or you can have again, items are always easy to think of. You could have something like editable, or you can have something breakable or unlockable. These could all be different interfaces. So think, one nice thing about using this as an RPG system is you could think of the things you would usually encounter in an RPG, and you think to yourself, what can I use this item with? Like, how does this item work? Can I eat it? Can I equip it? Can I carry it? Can I burn it? Can I melt it? So again, crafting games are a good way to start thinking in these terms as well. Did that help answer your question? Yeah, yeah. So yeah, like the aspects of an inventory basically, but kind of like the properties that items themselves would have inside of the game, and how you would actually be able to define that hierarchically from an interface down to a concrete class. So designing using interfaces first and then building down to concrete classes. So again, one thing I want to try to reverse that was probably instilled in you from 1583 was you were building concrete classes and then you built up towards interfaces. But in actuality, usually you do the reverse. Usually you build your interfaces first, and then you build your classes to implement your interfaces. So I'll say as many as you can justify. How many different aspects do we need to do? Something that is sufficiently like complex enough. It doesn't have to be overly complex, but I don't want something super, super simple. But I'll give a lot of leeway to that. So I don't want to create a hard definition that you have to have, say, for instance, 5 interfaces, because I want to give you the flexibility to design what makes sense. But I don't want something that's super trivial, right? I want something that's going to challenge you and your ability to design something that's, again, the keywords you're looking for is robust, flexible, and reusable, so that you're not rewriting that, so that your system, that you're just building on top of a well-defined system effectively as you're creating new items. So the idea behind this is, as you're extending the things inside your items, as you're adding new items, you can crib off of and use the interfaces you already have. And ideally, the code that would actually implement off of your item system would be using the interfaces as the data types and not any of the concrete objects. So like, for instance, a belt might have things that are carryable, or like the character might have items that are equipable, not a piece of armor and a sword and things like that. See, so you're using as the data type the interface and not the concrete class. And again, that's how it's typically designed in the real world. That's what you strive for, abstraction. You're trying to hold things at a more abstract level and not as at a very concrete level, at a very specific level, because it allows for you to be able to add more functionality to your software without having to refactor it each time you add new items. Let's see. Could we also have something like combining weapons to make a better one? Yeah, I would love that. That's exactly what I have in my mind, with being able to like merge things to build bigger things, or even take a weapon or do the reverse, maybe destroying a weapon and being able to get parts from it, like the iron from the sword, or scraps from it, like that. Yeah, I love those ideas, and it makes sense in this kind of assignment. Again, this is a trial assignment. This first time it's been had, so we'll see how successful it is. But I think that this is a cool way of trying to learn how to build code the way it's done in the real world. Yeah, you could do enchanting. Yeah, exactly. Like try to think of interesting mechanics that you've seen in RPG systems and think, how might you model that in your item system? That's exactly what I'd like to challenge you to all do. So yeah, material composition. So that like harkens to like that crafting game, that Minecraft kind of approach of either being able to combine things to build more complex things, or taking complex things and disassemble them into simpler things. Excellent. Is there any other questions that anyone has? Well, if not, I will go ahead and not cancel, but end today's lecture, and wish everyone a good day, and I'll see you all tomorrow.